recognize this. If I didn't have that 5x there, I recognize that if I had that, I would want to do the peeling off to make a good du with the sine or the cosine to the odd power. But I've got this ugly 5x in there. So that's what I'm suggesting to get rid of the ugliness and make it so that you don't make mistakes. Try a w substitution. So w equals 5x. So I get 1/5. Sorry, that's really messy. 1/5 dw equals dx. So then I'm going to say this is 1/5 cosine cubed of w dw. I chose the letter w because now you are ready to do your good du. You're ready to find the good du by peeling off a cosine. So this right here would be my good du. So my du is cosine of w dw. So that means u is sine of w. So let's change this using our identity. So you would replace this with 1 minus sine squared of w. And then cosine, let's move this, cosine of w dw. Cosine of w dw. All right, now I'm ready to go with my u substitution. So I'd have 1/5, 1 minus u squared, and all of this is du. Carry the 1/5, take the antiderivative. Remember, the antiderivative of 1 in u land is u, minus u cubed over 3 plus a c, 1/5, and then I'm going to put the u back in, which is sine. Oh, no, sine of w. Remember? Oops. I was thinking that and just didn't write it. Sine of w minus 1/3 sine cubed of w. And then last step is to put the w back in, which is the 5x. Lots to keep track of. Okay. So then looking at number 5, you see a radical. None of this tricky u stuff will work on that, but you're thinking, when I have radicals in my equation, or my integral, it can be nice to use a trig substitution to get rid of the radical. But wait a second, this one is not a squared minus x squared, or x squared minus a squared. It's got this x in there. So I'm going to suggest, and I'm going to pull it off to the side. If I have ax minus x squared, I'm going to be thinking, wait a second, in order to complete the square, to make a nice square, I want to factor the negative out of those first two terms. Now I'm going to do the completing of the square. So I'm going to take half of negative 8 and square it. So I'm going to add a 16. Oh, but I didn't really add a 16. I really subtracted a 16, so I add a 16. So this is negative x minus 4 squared plus 16. So that's what we're going to put inside the radical. So radical, the negative x minus 4 squared plus a 16. Okay, so details here. I want to encourage you, since you see this negative here, I want you to rewrite it so the negative goes between the terms. So first off, do that. Then I want you to do an easy u substitution. It'll make it cleaner and you'll more easily recognize what trig substitution to do. So let's see, how about if I say let u equal x minus 4 du, just dx. Okay, so this turns into 16 minus u squared du. You recognize it. Yes. So you know that this would be u equal 4 sine theta. Du is 4 cosine theta d theta. So then I'm going to substitute that in, and I'm going to come up here. So I would have 16 minus, substituting in for u, this, right? So I'm just going to go slow, 4 sine of theta all squared. And then don't forget, the most common mistake is to forget to put that in for the du. cosine of theta d theta. Okay, oops, d theta. So you know the reason we do this trig substitution is there is an identity inside the radical. That's going to get rid of the radical. So let's do it. So you see I can factor out a root 16, and I get 1 minus sine squared of theta, and then this 4 cosine theta d theta. So this 4 and this 4, you see it as a 4, right? Come outside to be 16, and you know this 1 minus sine squared is a cosine squared that's under the square root. So cosine squared square rooted is cosine. So get the 16 here. So I'd have one of the cosines times another cosine. So I get a cosine squared of theta. Whew. Now what? Oh yeah, we get to use the half angle formula. So carrying along the 16, 1/2, 1 plus cosine of 2 theta d theta. So this 16 and this 1/2 make an 8. I'm going to take the integral of 1 in theta land gives a theta. Do the La Jolla theorem here. Now I'm going to use the triangle to get the information back into x's. So it's triangle time. So this is the same as saying u over 4 is sine of theta. So if that's the angle theta, opposite over hypotenuse. And then if I needed to solve for the other side, which I do, I get this, and that's my little happy moment. That is the expression in my original problem. Oh, no, but I can't get sine of 2 theta off the triangle. So what do I need to do? I'm just going to go slow. I need to replace sine of 2 theta with the identity 2 sine theta cosine theta. Those 2's cancel. Now I'm ready to find out, how do I get theta? Oh, right. I take this and I take the inverse sine of both sides. So this would be the inverse sine of u over 4 plus sine of theta, you know, is u over 4 times cosine 16 minus u squared over 4. And then what's the u equal to again? Oh, yeah, x minus 4. Good thing you have it written up there nice and neat. So sine inverse x minus 4 over 4 plus x minus 4 over 4 square root of 16 minus x minus 4 squared over 4 plus c.